Hi there, welcome to a quick look at the problem that was having everybody get a little too anxious at the end of class today. So we had a problem about Angelina, who deposited 3,000 in savings in an account on January 1st, 2019, earning compound interest of 1.5% per year. So it's compound interest, it says per year. It wasn't particularly clear here about how many times it's compounded, but it does say per year, so we're going to assume it's just compounded once per year. So we don't really have to split this percent over months or quarters or anything. Also, this problem is not so bad. It seems like in the last 10 minutes there, everybody was running around trying to figure this out. There's a lot of anxiety in the room, and then there wasn't like a peaceful moment to think about this. But when I did have that moment after everybody left the room, I noticed it's not so bad at all. So let me show you how this works. Let's look at part A first. So she invests 3,000 and the interest is here, and we're supposed to figure out how much interest she will earn after 10 years. So it's compounded once per year. Well, it's compound interest, so let's use the compound interest formula, which is in your formula booklet. Into the formula, we're going to put in the original amount, the principal, 3,000, 1 plus the rate. And using this formula, right, we divide the annual rate by how many compounds per year. Here's the annual rate of 1.5%, but we're putting a 1 here because it isn't compounded monthly or quarterly or whatever it is. It's just once per year, so we just put a 1 there. And here we put 10 years times the number of compounds per year, which is 1 again. So essentially this 1 and this 1 are kind of irrelevant here, and we can just simplify it into 1 plus that, which is 1.015 to 10. And that tells us that it is compounded 10 times, once every year, and we're going to get an amount. That amount is this. However, the question was asking for how much interest she will earn, not how much will be in her account. Because if you put this money in a bank account and you're earning this kind of interest, this is the balance you will see after 10 years. So you will look in your account and you'll say, oh, look, there's how much money I have now. But here it was asking about how much interest she earned. And interest is the extra money you earn, not including your principal or the amount you put in. So take away the 3,000 you put in, and the extra earned, or the interest earned, is 481. Now let's look at part B. This is the part that was really getting people confused, and people were jumping ahead of slide, looking at the answer, getting confused by what they saw. Let's break it down. This one is not so bad, really. So here we have, on January 1st, 2019, she deposits a further 1,200 into that same account on an annual basis. So every year, she's going to have that amount she had in there, and she's going to add 1,200. And then the next year again, in 1st of January, she's going to add 1,200 again. And the next year, she's going to add that amount again. The thing that happens with those amounts you add, I mean, at first glance, you might think, okay, I'm just going to do, well, 10 years of earning of 1,200, 10 times 1,200, and I have an amount. However, each time she puts in that 1,200, it will continue to earn interest at that 1.5% rate. So this amount, if you put in the first year there, it will be compounded over 10 years. So let's take a look. So in 2020, she deposits an extra bit. She deposits this much. However, that amount will sit in the account for the next 10 years because it's going to be from 2020 all the way to 2030. So it'll sit in there for 10 years. And just like we had here, the 3,000 for 10 years earning interest, now we have this 1,200, and it's also earning that same interest for 10 years. So that amount will grow to a certain amount. But that's not the only amount she's putting in. Then in 2021, she deposits another 1,200 because she's going to do that every year. So that amount will grow over this time, not 10 years, but 9 years, because this will sit in there from 2021 to 2030, 9 more years. So this amount will compound and gain money over 9 years. And you keep doing that all the years through. I've skipped all the years, but you get to the final deposit she makes is 2029, because it says in 2030 she's not making the deposit. And the last one she puts in, there it is, it will earn interest, but only for 1 year, because it will earn interest from 2029 to 2030. So that one will be like that. So imagine all these amounts between here and this countdown, 10, 9, 8, 7, 6, 5, and there's all these amounts. Each of those 1,200s will gain money and become its own bigger amount. So now we have a sequence of deposits, and I'm going to put them in order, in reverse order. I'm going to write this one first in my sequence, then the next one, the next one, next one, next one. So here's our sequence. We have this amount that she will gain, then she'll also gain this amount, and then, right, there's this one, and then the next one, and then next year, and so on until all the way here, dot, 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 until back to this one, which is the 1 times 10. So again, these are the amounts, a sequence of amounts she will add to her account, like because she had that 3,000 originally, but now she's adding this much and this much again and this much, and all those amounts are growing. So this is a sequence. If you multiplied these numbers, you would get some value. But I'm not going to do that step because I'm going to try to skip that step and show you what's happening here. If you multiply that, you get a value. Multiply that, you get a value, and so on and so on. You'd create a sequence. If you check that sequence, you would notice it is a geometric sequence. But we don't need to multiply these to check what numbers we get here because we can already see this as geometric. If this is like term number 1, then we can use the UN rule to figure this out, right? And we look at this and we're like, oh, I can see that's geometric. It's some amount times a rate to the n power, right? And then some amount times a rate to, so really this tells us what our U1 is and so on because we're just multiplying by the same amount every year. So that might be tough to see, but basically, if we call this our U1, to get the next value, U2, we've taken this and just multiplied it by 1.015 again, because if we multiply this by 1.015, we end up getting 1.015 to the second power. And then the next term, you'll multiply by 1.015 again, and you'll have 1.015 to the third power. So this is like our R value, and this is our U1 value, all this. So now the goal is to figure out how much she has in total, it says, in her amount, in total money in her account, which will be the sum of all these amounts, right? If you take this and add this one and add the next one, add the next one, add all those up, those will be all that extra money that she has in her account. So the sum, if we're thinking sum, and this is geometric, well, we're going to have a sum of a geometric sequence. So here's our sum formula. And we want to sum all these values in this geometric sequence. So our U1 again is what? And how about our rate? What is our rate? Okay, let's check. So here is our U1 value. This whole bit right here is U1. And that's this part here. That's the first term in our sequence. And over here, where we have to have the rate, I've put in this rate. Because like I said, when you go from here to here, you're just multiplying by one of these to get this one. So there's our rate, and it's raised to the n power, so 10th power, because this sequence has 10 terms in it. And then this formula tells us -1, and on the bottom we have rate -1, so the rate -1. So there's our sum formula. And that's not the total answer to this question, because the total amount in her account is not just all these extra 1200s and how they grew, but also the original 3,000, which has sat in her account now from 2019 to 2030. So it's 11 years of the original 3,000 as well. So this sum, which is all these added up, plus that 3,000, is the total amount in her account in the end. And that total amount is shown here. So now if you look at the answers here, this, you should be able to see where all that came from. It's this idea here. I hope that helps you. If not, let's talk next class again, because these aren't so bad. You just have to take it slow. Don't get all anxious. Don't run around trying to ask everybody questions. Just ponder it for a moment. Think about what the unit's about, sequences, write it out. If you take your time and just take it calmly, you'll get there. All right, thank you.